My name is Agnes, and I'm Event and Community Manager at Code Chrysalis, but most of you already know. And I will just give a stage to our wonderful speaker tonight.
Thank you. My name is Stefan. Oh, please.
I'm so sorry. I was just
Okay.
excited to give the stage to you. Just one housekeeping. At the end of the presentation, we'll have a Q&A session. So if you have any questions, please use the Q&A section. For any comments like, oh, that's so interesting, please use chat. There you go. Thank you.
All right. Very good. Thank you. Okay, so I'm just going to boot up Sheen's screen sharing and PowerPoint. All right, I'm going to move this. All right, so you should be seeing. Okay, the PowerPoint presentation. All right, so procedural audio with pure data. Here's the program for my speech, my talk. I'll give a brief introduction about myself, and then I'll talk about pure data software I'm going to be using today. And eventually at the end, I'll be giving a demonstration about how to make an audio plugin using pure data and converting it to be used in Unity as a native plugin. So, oops. I'm not sure what's wrong with the order of my slides, but okay. So my name is Stefan. I studied viola, and then I moved to Europe where I started studying composition and electronic music. I'm from the US originally. I live in Tokyo now, and I develop and exhibit interactive digital art. I also do concerts, also using pure data. Oops. I need to practice more using PowerPoint. Okay, there's my website, selliotp.com. At the end of the talk, I'll be putting a list of links in the chat that I've had here in the presentation, and I think Agnes will also be sending them by email. There's also my Instagram and my YouTube SoundCloud. If you just search for that name, it should show up. All right. Oh. And yeah, pure data is the software we're going to be using today with Unity. So it's a node-based programming language. And yeah, it's used for live synthesis, so it's often used for electronic music or hybrid acoustic electric music. And I learned about it at university as part of my studies in composition and electronic music. And it was created by Miller Puckett, who's famous also for making Max MSP, which is a better known software. But they're very similar. They use the same node and wire-based interface. And the difference is that Max MSP is the more commercial version, so maybe you get a lot of resources and documentation, whereas pure data is open source and community driven. So you do also have a lot of resources there, but yeah, it's a little different. The good thing about that is, of course, that you can also, you don't have to worry about legal issues maybe when trying to integrate pure data into other softwares because it's open source. So yeah, I have some links here to puredata.info where you can download it and find links to tutorials and other resources. A good tutorial is also pdtutorial.com, and there's a forum also here. All right, and what I'm going to be talking about today is using pure data not only to make, synthesizer-like sounds or fantasy-like sounds, but to make realistic sounds. And I studied a lot this subject using Andy Farnell's book, Designing Sound. And he actually uses pure data in this book to demonstrate his methods. So there's a big theoretical part of the book where he talks more generally and goes into the science of sounds and how certain sounds are made. And then he has a practical section where he shows you how you can use pure data to make a specific sound and make it interactive. And so this is a very important book for me. And then here I have another book, Real Sound Synthesis for Interactive Applications by Perry R. Cook. This book, I believe it's referenced in Designing Sound in the previous book there. And Perry R. Cook, he doesn't use pure data in his book. He just describes the techniques more generally. He's also the inventor of Chuck, which is another software for live generative sound. And he has an online course which uses Chuck, if you're interested in checking that out. And then Sonic Visualizer is a software for analyzing sounds and their spectra. So yeah, those are just some resources if you're interested. All right, so today we'll be looking at using pure data with Unity and other platforms, well, specifically with Unity today. And there are 3 methods that I have here for how you can integrate pure data into your interactive digital media project. The first is Hvcc, also known as the Heavy compiler. This was made by Enzian Audio, which is since disbanded, but it's now open source, and there's a small community for it. And that's what we're going to be using today. But there are other options. There's also libpd, which is an embeddable version of pure data. So that's the difference. So with Hvcc, the compiler, it actually takes your pure data patch and it translates it into C, and then adds wrappers for C# and other platforms. But I think libpd actually uses the pure data code more directly. I tried using it once and I couldn't get it to work, but some people use it, I think. And then there's Open Sound Control, OSC. So this is a way to send messages between different programs, so audio messages on your computer. And the good thing about this is that you can use pure data in its direct vanilla form, and you can use it with a lot of different softwares. The bad thing is you can't make a build, which is something you might be interested in doing, right? If you want to release a video game onto a store. But if you're just exhibiting something, like an installation, then it should work nicely. So, oh yeah, and then I have here at the bottom NN game. So NN is a video game that I did the sound for using pure data and the Heavy compiler, Hvcc. And I mention it here because it was actually made in Objective-C, and I worked together with a programmer to do the sound for his game. So I constructed the plugins. I exported using Hvcc. You can see the options here on the right. And I generated a C build of the plugin, or of the plugins, and gave them to him, and we set it up together. And I would tell him what values I need in the to go into which parameters, and I would give him charts, Excels of parameters for every level of the game, right? So I could reuse the same plugins but have very different sounds. And yeah, I'm bringing that up because Actually, that's the only time I've used Hvcc not with Unity. So I know it's possible. I know it works with other platforms. Oh no, that's not true. I did try building a VST2 once, I think that worked. All right, so we're going to have some demonstrations. So first I'm going to show you a trailer of my most recent interactive digital piece. It's an art piece called Hvcc. And we're going to look at that. It sums up nicely some of the interactive sound in the project. And then I'm going to use sort of the Hvcc template of interactivity. And I'm going to show you how to construct a very simple plugin from scratch in puredata and how to implement it in Unity. And then we can, if we have time, we can look at another project of mine and take a look at a more complex plugin. So without further ado, exit this. And I'm going to switch to the second screen actually, because I have two screens here. Okay, you see the pink ball, right? Thank you, Agnes. And let's watch a video. Oh, let me make sure I shared my sound. Hold on. Yes, I did. Okay. You see the pink ball again? Oh no, I shared the wrong screen. Okay, that should be right now. Okay. Can you hear it? Okay, so that was the sort of demo trailer of Eurydice or RDDK. And yeah, we're going to look at this pink floating ball here and how to make a simple plugin from scratch and use it in Unity. So I'm still sharing my second screen, so I'll open up pure data here. Okay, so here is an empty window, empty patch in pure data, so we can turn on digital signal processing there. Oh, fix the settings now. Okay. So in pure data, we have a menu here, put, the object, message, number, symbol, comment. The most important one is object, though message is also very important. And we have, these are shortcuts, of course, so Control-1, and I can make, I type in OSC, which stands for oscillator, and that creates a sine wave. So you can see a picture of it. If I put in, I have to put in a value actually for the starting frequency. Like that. Okay, so there you see the sine wave. And if I want to hear it, I need to create another object and type in DAC tilde. So this isn't really, going to teach you pure data. It's best if you take a tutorial, but I think you'll get an idea of the basics by watching this. So if I put this directly into the output here, it's going to be a little loud. So I'm going to put multiply. The tilde there means it's an audio object. So multiply times 0.1. So that'll make it a bit quieter. And now you should be able to hear it. All right. So I'll let that for a moment. And let's say we want to change the audio. So if we want to change the oscillator's frequency in hertz, we can make a number box, Control-3, and we can put it in here. Move it around. And if we want to make the changes in notes a little smoother, so if we listen now, it's not so bad, but there's a little bit of flicking sometimes, a little. And so I'm going to put it in a message, Control-2, $1.20, and into line of tilde, and put it into the oscillator. So what this does makes it a bit smoother, right? So the way that works is the dollar sign represents the incoming value. So I have 224, so it goes in here. And then this message outputs two values. It outputs 224 and then 20. And what that means when you put it into a line object is that it outputs a transition from your current value to the new value. So in this case, 224 in 20 milliseconds. So it smooths things out in our case. All right, so next we're going to do something. So we can think about what kind of interactivity we want in our game. So we have a bouncing ball, And so maybe we can change the pitch based on the velocity, based on how fast it's being moved. Okay, so that's already one parameter we have set up here. And if we're using heavy, the Hvcc, right, we can expose parameters. So here a receive object, which is normal in pure data to use send and receive objects. But if we want to expose it in our plugin, in our heavy plugin, we add @hv_param, and then we put our minimum value, our maximum value, and a starting value. So we can put that in here. And you don't need to do this, of course, but I'm going to hard code the ranges into this plugin, into this patch for simplicity's sake. So I'm going to say, in Unity, we have a value between 0 and 1, and we put it into this patch. And then when it comes in here, it gets converted. It gets multiplied by 237 and added to 100. So that'll give us a range of between 100 and 337 hertz. Right? And we can make, for testing purposes in our patch, we can make a little vertical slider here, right, which goes between 0 and 1. And there we can see that transition happening. We can hear it now. All right. So there I'm simulating what we will be later doing through Unity code and this plugin. Okay. So next, we can think about what other parameters do we want. We can have a parameter where something happens if we're holding this ball, this bouncy ball here, and something also happens if we release it. Okay, so a simple way to do that would be to have a multiply object here. And here I have a toggle object. So a toggle is either on or off. It actually just sends out 1 or 0, right? And again, we'll send that into our line object, just like with the oscillator, but we're going to use it here to control the volume instead. And yeah, so if I do this, it sends out a 1, right? So now it's multiplying the incoming oscillator signal by 1. And if I send in a 0 here, it multiplies it by 0, so nothing happens. Nothing is heard. Right? So I could use this, I could make the envelope longer, maybe 5,000 milliseconds, or maybe 5 seconds. And I can make it so that when you click the ball, the sound gradually fades in. And when you release it, when you stop touching or clicking on it on the screen, it gets released, or the fade out happens. But I want to do something a little more interesting here. So we'll make our receive object is touched HV param 010. Okay, and what we're going to do is we're going to use a phaser. I don't want a simple fade in and fade out. I want to have a pattern to the sound. Okay, so to show you what a phaser does, it's also a wave generator like the oscillator is, but instead of a sine wave, it creates this. So I'll move it a little faster. So it's a wave that starts at 0 and it goes up to 1 in a straight line and then jumps back down to 0. Actually, it has a sound if you want to hear it, but oh, my bad. It's like a rougher sound than the oscillator. All right, but we're not going to be using it for its pitch. We're going to be using it to control the volume. And the way we do that is we have our incoming is touched value, which will be either a 0 or a 1. And we will multiply that by 9.7 plus 0.3. So that means when it is not touched, the phasor will be at 0.3. And when it is touched, it will be at 10. So if we do a transition again, here I'm going to use, since I'm not using, since I want the phasor speed, the length of the transition to be variable, I'm going to, let's copy and paste this, another exposed parameter here. And I'm going to use pack F5000. I'll explain this in a second. And we use a line here. Okay, so we can simulate this here. So you see the phasor getting faster, and now it's getting slower again. So if we replace this, remember we had our switch here that faded the sound in and out. We're going to get rid of that. We're going to put this into it instead. Actually, we'll keep this maybe. Yeah. All right, so we'll put it in here. And now we see the sound getting very rapid, and then when we let go, so we see it's constantly getting louder and then going back to 0 in volume, right? Now it's doing it very slowly. And then when we touch the object again, that pattern gets faster. But I don't like this clicking sound, so I'm going to add a low pass filter under the phasor. And what that does, it rounds out the shape of the phasor, because the phasor, it goes straight from 1 to 0, which is what's creating this clicking. And now it's a little smoother. All right. So also, I think I want to do both. I want to have this this phasor pattern, but I also want to fade the sound in and out. So I'm going to duplicate my is touched receive object, and it has to be identical, right? With the values here. And I'm going to use another pack. So, oh yeah, I was going to explain the pack. The pack, it's just like using a message, but it allows you to set variables for both values instead of just the first one, as was the case here. So pack 5000 again. Yeah, in case I want to change the speed of this transition, with the speed of the phasor, then I can also set that as a variable here. Set that here also. Okay, and then we can put this, the output of this phaser pattern in here. And put our oscillator here. And then we'll have another multiply box. Here. So what I'm going to do is, so since I'm simulating the sending of values via Unity, right, I click here and it sends the one to both of these receive objects, right? Because it's a send object that corresponds to them. Right, and then I put that into the output. Should work. No. Yeah. So these little boxes, these spectrum boxes are neat because they allow you to see different phases of the sound transformation, right? So here you can see what the phaser is doing. Here you can see the end result of the complete sound. All right, and then I want to think about what happens when the ball collides with a wall, right? Because if you look at the Unity project, we have these walls here. And yeah, it should make a fun sound when that happens, right? So again, we're going to do something very simple here because we only have so much time for our talk. So I'm going to have a receive object E bounce, right? E standing for event. Oh yeah, that's just how I label them personally. So U for values that are updated, and S for values that you set at start, kind of like in Unity C#, right? And then E is an event, so HV underscore event. And that's just like a function call. It doesn't send in any values. It just tells the patch to do something. All right. And then I'm going to use my, I'll just copy and paste this actually, my velocity value here also. So depending on how much velocity the ball has when it strikes the wall, you know, we use that value for our bounce sound. Okay, let me use another message, Control-2 and $1, 10, 0, 510 into, so the normal pure data object would be vline, but there's a heavy compatible one that I'm using called hv.line. And what, oh, sorry. What vline does is it's the same as line, but it allows you to have more complex like sequences of messages. So this just means it goes to the new value in 10 milliseconds, and then it goes to 0 in 500 milliseconds after 10 milliseconds have passed, right? Because this one takes 10 milliseconds, right? And then that goes, I want a more natural, you know, percussive attack sound. So I'm going to multiply this value, which will be between 0 and 1 by itself. So I'll raise it to the second power. And I'm going to make a fun sound by using another oscillator, which I will just arbitrarily set to 471 with its pitch. And there's a technique called amplitude modulation, which is where you use one frequency to change the amplitude of another frequency. And when you do this at very fast speeds, it creates a more complex spectrum of sound. So to do that, you take your modulator frequency, you add 1 and divide it by 2 to explain that very quickly. Right. So normally the sound looks like this, but since I want to use it to change the volume, if I add 1, so yeah, sound is normally in the -1 to 1 range. And then when I add 1 and divide it by 2, it puts it in the 0 to 1 range. Right. So I'm going to take that and multiply it by the carrier frequency, which is our original oscillator, and you get this sound. Okay, so it's a little different from our original sound, right? And I'm going to blend between the normal oscillator sound, right? So this and the modulated, amplitude modulated sound. And the amount I blend is going to depend on the velocity. So we have our HV line to do that, our V line. And we put, well, I'm going to make, yeah, we put that into here. So let's say we get a velocity of, so let's do this. So if we have velocity of 1, so that would be the max velocity, then when a bounce occurs, we transition all the way to this modulated sound, all the way up to 1. We turn it all the way up. And at the same time, we invert the value. Okay, so that means 0 becomes 1 and 1 becomes 0. And we use that to turn off the original sound. Okay, so sig1 is it's sending out a constant audio signal value of 1. So that goes in here. And that in turn comes into here. All right, so this just means that when a bounce occurs, we can simulate that with a bounce button. What's going on here? Okay, so it's working there. So when I press the bounce, you hear the transition to the amplitude modulated value, amplitude modulated sound. And once those 510 milliseconds have passed, it's back to just sending out a 1 here, which then gets multiplied by the original oscillator sound. So you just get the original oscillator sound. Okay. And then if we put this back into the other things we did with the volume. Oh yeah, we have to touch the object. And while we're touching it, we can change the frequency. And we can let it go, and it bounces and hits some walls. Okay, so it should be, yeah, it's fully functional now. it does a few things. We could also add a master volume parameter and just stick that there. Okay, and that's it. Our patch is done. So I've already compiled this patch, and we can look at it here in Unity. And let me see. Oh. Okay. So here's the sphere object, and a child of that is that simple audio, and this is the plugin we just made. So we see that our HV event, right, bounce has become this button here, which you can press in play mode, and then our HV parameters have become these sliders. Okay, and they have their default values, or I may have changed the value of this one to make it a little longer, the phasor envelope speed. And we can also access these through code, of course. So I have here a simple audio controller, which is linked to my other patches, right, that control the movement of the ball. So here you can see the simple audio controller. When grab is called, so that means that I've touched or clicked the ball. Yeah, it sends the corresponding value, right? 1 when grabbed, 0 when released. And it sends it to the plugin, and the plugin is called in this way. Zoom in a bit for you. All right. So it's an object of type. It has its own type. So it's HV, and then I named it procedural demo, and then audio lib. And you call it, and then you call its function set float parameter, and you call this enum here parameter dot u is touched, right? So that's the parameter that I named in my pure data patch, right? Is touched here and here. Okay, and so you set it there in real time. So when you do that, it should behave as it did when we were testing it in pure data. And the same thing for collide. When we call that method, it sends the event. So instead of set float parameter, it's send event. Right, the event is e_bounce. And then update, we continuously update the velocity value, which is important for changing the pitch of the sound, and also for the bounce sound as well. So yeah, we calculate the velocity here. You know, we look at the velocity. So basically, I would experiment moving the ball around and seeing what its velocity values are, and finding a good range that I want to scale. Uses a scaling value, right? So you get the value between 0 and 1. And yeah, then I use math clamp, and this is where I calculate the velocity based on its previous position. And then I take that final velocity value and I put it into our plugin right here. Okay. And yeah, we can have a look at how that works, or how that sounds rather. So let me press play. So when I touch it, right, the sound fades in, and also the phasor sound. The phasor sound gets faster, right? It's going ba 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 ba. Now when I let go, it slows down and the sound also fades out, right? Okay, and I'm going to touch it again. And now when I move it around, you see the pitch is going up and down, right? Because we used our velocity to change the frequency of our oscillator. Okay, and now if I move it around and let it go, it's going to bounce and hit the walls. So we'll get our bounce event, which is also velocity based. Yeah, it fades out eventually because we're not touching it anymore. Yeah, so that's it took me a lot longer actually than I thought it would, but that's an example how you would build a simple patch and turn it into a plugin to use with Unity, and how you would use it using the Hvcc, heavy compiler. So I don't think I'm going to have time to go over the more complex patches I wanted, but if we have time, I can show a short demo video of that. So this is a less artistic project. This is something I made specifically to show the possibilities of procedural audio with interactivity. You know, to show how you can do things with it that you can't do with only using samples, right? So it shows a lot of sort of gamish tropes, like from a first person, yeah, explorer or shooter perspective. Oh, no shooting actually. Let's just look at it.
Stefan, you're muted.
Thank you. Yeah, I have the impression that the audio doesn't sound too good when played over Zoom. Like it sounds very quiet for me. So if you're interested in the concept, please go to my website and my YouTube and check out the original videos. Yeah, as you can see here in this demo, I've created the plugins and I've attached them to objects in the 3D world. So it has the effect of spatialization. You get to use Unity's options for that. You can also add Unity audio effects on top of your pure data plugins, so like reverb. And yeah, I think I've already gone over, so maybe we should do question and answer.
Yeah, if you have any questions, please let us know in the Q&A section. And maybe while people are typing, if there's like anything else you want to share, you still can.
Oh, okay. I wasn't sure how strict the rules were. Let's see. Is anyone typing anything?
It usually takes time.
Okay. All right. I'll go ahead and I'll talk about that video a little bit. So what I was planning to look at was this moving platform, right? Oh, I have something in the chat. That's not Q&A, right?
That's not the Q&A. That's
I
people
just ignore that,
appreciating.
right?
That's interesting.
Oh, well, let me read it anyway. Oh, thank you. Someone, was it Thomas? Someone said, oh yeah, Thomas Logan said they'll look at my website. Thank you. And Grant, thank you for hyping me up. All right, and Q&A. Oh,
Yeah, we
I
do
have a
have.
question. Anonymous attendee. I have a question. When I want to make sort of music application, what should I use? Oh, you want to make a music application? So yeah, you could use the methodology I just outlined. If you remember the first demo trailer I showed you, Eurydice, there are two instruments in it. There's a lyre and a flute, and those sounds are completely procedural. And depending on input or other parameters, you can vary the sound a lot with that. So actually, yeah, since you asked, I guess we could take a look at that patch. Hold on a second. Let's look at the lyre one. I'm a bit happier with that one. Okay, so I'm going to share my screen again. Okay, so I'm opening up the patch for the lyre string sound, because the lyre also has body. So I didn't set this up to be easily legible, but you can see our, should probably zoom in a bit, right? It's probably hard to see. So you see I have a lot of receive objects. These are exposed parameters in Heavy. And so when I grab, it does this. When I release, it does this. Okay. And I can set a lot of start parameters. Actually, I'm going to zoom out again because zoomed in is not great either. And I think if I, oh yeah, so if I grab it there, it plays a chord. And if I release it, oh yeah, I have to multiple times. Oops. one second. That's happening because hold on a second. Right. So every time you hear an individual string or a chord, it's activating these abstractions here, string. So that means it's just the same thing multiple times, right? Like a function that you call multiple times. And if you open that up, right, you have the actual synthesis happening here, which is a synthesis technique called car plus strong, which is great for producing string-like sounds, which involves using a delay with feedback and a low-pass filter, right? So basically the sound keeps going through a delay, it keeps getting looped into itself, but because of the low-pass filter, the higher pitches die out sooner, die out gradually, right? And that creates the sort of sound like you would get from a string. And here, yeah, you can see oscillators. I use a mix of oscillator, like from our previous patch example, with some noise mixed in also. And I can change the filtering based on, you know, how much of a sul ponticello sound I want. So yeah, so if I want an ordinary sound, I have it here and it goes, right? But if I want a more sul ponticello sound, it goes, and I can transition between those two with this parameter here. Actually, I haven't exposed this parameter because I just set it up so that it's randomized, but you could expose it and have it so that in your app, depending on where you pluck the string, where you pluck the string that's visualized in the app, that you get a different sound, right? Because if you pluck a string close to the body, you get this sul ponticello sound, right? But if you pluck it closer to the middle of the string, you get more of a sound like that. Does that answer your question, anonymous attendee? Oh, wait.
Yeah, I think that answers the first question.
Yeah,
There was a follow-up question,
yes,
though.
is there any application on Public that I can use, or is there any program on there? I have an idea to gather other musicians' audio stem files onto one website. Audio stem files on one website. What program is best? Well, if you just want to use, do you mean samples like audio recordings? If that's what you mean, then you could just do that in Unity, actually. Just use the samples and call them. Like the reason to use something more complex like pure data is to, you know, have this option to increase the interactivity. Audio stem files to put into one web. So you want to create like a database, not an interactive application. I don't know. I guess you could do it in a lot of ways, right? You could put it, make a zip file and put it on GitHub. I'm not sure I get the question. You're saying you want like to have like a nice interface and a website. I guess for that you would use HTML or something.
Thank you. Yeah.
Sorry if I wasn't that helpful there.
Yeah, I think it's just not like the field that you're in exactly.
Right.
Yeah. That is, if you want to create a database, then with audio files, then it's more on like different type of programming, I would say.
Yeah, I would say so too.
Yeah, I'm
No
sorry. Okay. If there is no other questions, then I think we'll be wrapping up.
Do you have any questions, Agnes?
I mean, like, you know, I did graduate from music school, and I was playing cello before, and I would say like this is the first time ever that I see music written in that way. You know, I would never imagine music can look like that. I was even taking screenshots, like, you know, like this is how actually music looks like.
No.
This is how sounds looks like.
I mentioned it in my presentation, but so I play viola, and I started hooking my viola up to Pure Data with a contact microphone. So and in Pure Data you can have pitch detection and amplitude detection. So depending on, you know, what pitches I'm playing and you know how fortissimo I'm playing, it will control the synthesizer sounds in that way. So the synth sounds will also get louder and become higher pitched. And then recently, I mentioned that I bought a 5-string Midi violin. Yeah.
Oh.
So it's an electric violin, but it sends out, you know what Midi is? Midi. So, hello? So
yeah.
Midi, it's a sort of very universal signal that's used for controlling, you know, like if you hook up a keyboard to a synthesizer or to a computer, it will send out note values and whether the note is being played or not. So you can control, you know, other sounds using like a Midi keyboard, right? So this instrument, it sends out Midi signals, and it sends out a unique signal for each string, so I can control like 5 different sounds at the same time by playing a different string. So, and that's also with Pure Data.
At that time when I was attending music school, I wouldn't imagine actually.
Do you still play? Do you still have your cello?
Science with music.
Do you
Sorry?
still play? Do you still have your cello?
No, I quit when I was in music school. Because, you know, that time when I was playing cello, there was like either it's music or it's like, you know, science. Like you couldn't, like, you know, join both.
Right. You chose science.
If I knew at that time we can join that, I wouldn't quit, I think. Really.
It's not too late. Agnes, you can still pursue your dreams. Doesn't have to be this way.
Oh, you make me feel very guilty right now.
I'm just kidding. Don't feel guilty.
I think there's no more questions coming.
Yeah.
Only okay, thank you for answering the questions.
Hmm.
So we will thank everyone for attending tonight. And we'll be probably
oh, I was gonna post that list of links in the chat.
Oh yeah, you can post that those links. I will be also sending out emails tomorrow. Cool. Oh yeah, thank you so much.
Yeah, thank you for having me.
Always very happy that you actually I know it's a niche field, but I'm really, really happy that you responded to our like, hey, let's have Unity talk.
Of course. It's because it's such a niche, I'm happy whenever anyone shows interest.
Yeah. And yeah, thank you for everyone for attending tonight. I hope that you learned really a lot. And we'll be having probably another Unity talk at some time. So you can just check our meetup page to see for the newest updates. And we'll be wrapping up. So I wish you all a good night and hopefully see you soon. Sorry?
I should have done it in Japanese. The two other people here are Japanese.
Oh, it's okay. Like the event was like the description was in English, so I think they knew it's gonna happen in English.
すいませんでした。
ありがとうございました。So thank you everyone and hope to see you again. Bye.
And